What's good, Grizzlies? Algebra 1. I hope you had an awesome weekend and a good Mother's Day. We're starting the week off pretty easy. We're still in Vertex form. Today is all about describing the transformations. How is the graph moving around? How is it changing? Let's get started. So right here you see a picture of the parent function, the OG, the original graph, y equals x squared. It's in black. And what we're going to do is we're going to take the quadratic equation that's written in Vertex form and describe what happens when the a value, the h value, and the k value start changing. Let's start right here with the a value, pretty simple. So we're starting here with an a value of 1. You can see the red graph is right on top of the OG, the parent function. Nothing has changed because this would be an a value of 1. We have 1x squared. Watch what happens when the a value gets bigger than 1. You can see the red graph starting to get a little bit thinner. We like to call that a vertical stretch. Now, when the a value gets between 0 and 1, watch what happens when it gets smaller than 1 here. Once I'm between 0 and 1, you can see the red graph is getting wider than the parent function. We like to call that a vertical shrink. Now, if a becomes a negative, you can see that the parent function is just getting reflected over the x-axis. We call it a reflection. It's identical, it's just being reflected. But if the number here is still bigger than 1 or less than negative 1, check out what happens. You can see here, the larger that negative number can get, it still becomes a vertical stretch. It's getting thinner. But if I'm between 0 and negative 1, watch what happens when I get inside negative 1 here. The red graph is becoming wider. We call that, what's that called again? A vertical, that's right, shrink. So all the negative does is give it a reflection. If I have a number bigger than 1 for a, it's getting thinner. It's a stretch. If I have a number between 0 and 1, it's like a decimal, that's going to make it wider. We call that a shrink. Let's check out h and k. So now changing the h value, look, I put a -5 in here. Remember, we always use the opposite of h when we're finding the vertex. So where did the red graph shift to? Which direction? It moved to the right. Sometimes that's a little confusing because this looks like it should be negative or minus or left, but we always use the opposite of h. So -5 means that the graph is shifting 5 to the right. In this example, the red graph is shifting in what direction? Yeah, it's moving to the left. It's actually moving 3 to the left. Since we have +3 here, we're moving to the left. Remember, we always use the opposite of h to find the vertex. So anytime you're adding a number here, the graph is shifting to the left. Anytime you're subtracting a number here, the graph is shifting to the exactly. Pretty simple. So the h determines if we're moving left or right. The a value determines if we have a stretch or a shrink or if we get reflected. Let's check out the k value. What direction did the red graph shift here? Yeah, it definitely moved up. And the reason why, we have a k value of +2. Remember, the k values are exactly the same. So plus means it goes up. What if I put -2 here? Exactly, the red graph would shift down 2. So let me put an equation up here. Let's describe all the transformations to it. Looking at this example, we have an equation, and just by the red graph compared to the black one, I can see that it's thinner, which means it has a vertical stretch. I could also see the vertex move to the right and also move down. But I can be very specific looking at just the equation and not even having a graph. Because the a value is bigger than 1, I know it has a vertical stretch. Because the h value is -1, that means it moves to the right. So it's going to shift to the right 1. And then the k value is the same. -2 means it would be shifting down. As you can see right there, it's moving down 2. So I'm describing the transformations of this equation written in vertex form compared to the original, the OG original graph. So if I took this graph and I did these 3 things to it, it looked like this red one. Here's one more example. We've got the equation. First, even just looking at the picture, I can tell it's shifting to the left. I can tell it's flipped upside down. And the red one looks a little bit wider than the original graph, the OG. So the negative, that tells me that this is getting reflected. The 1/3, that would be a number between 0 and 1. So that means I have a vertical shrink. This +4 is the h value, which means it's shifting to the left 4. There is no k value. You can tell that the vertex, it didn't get moved up or down. It stayed right on the x-axis. So there's nothing to explain there. Here would be all the transformations of this equation. So today, pretty simple assignment. You got 5 equations. All you got to do, describe the transformations that you see. If you submit an assignment and let's say you only get 1 out of 5 right, it's totally okay to resubmit that assignment again as long as you do it before Monday, 3 p.m. I usually grade everybody's work Thursday mornings and either Sunday night or Monday morning. So if you get a grade back and you want to get full credit, if you missed a couple or you missed them all, you can always resubmit the assignment for full credit. Let me know if you guys need help. Here are the 5 problems we're going to do. Have a great day. We'll see you tomorrow.